In the last class, we have constructed a replicative strategy and suggested that the option price can be taken as the initial investment into the replicative strategy. In this lecture, we will prove that the option price that we suggested in the last class will hold in a no arbitrage market. More precisely, let us try to prove the following theorem. The theorem says that for a given option, if pi 1 is obtained by replicative strategy in a no arbitrage market, then the price of the option at t equal to 0 is given by the expectation of ht star. If you recall, in the last class, we have shown that the value of the portfolio at t equal to 0, that is the initial investment into the replicative strategy, is indeed given by E star ht star, right? So therefore, this says that you have to take the option price as the initial investment into the replicative strategy. Okay, so in our usual notation, we call it as B naught, and the basic definition of it is phi1 B naught plus theta naught S naught is what is given by the initial investment into the portfolio pi 1. Since we assume that pi 1 is a replicative portfolio, we have derived an expression for, this is theta 1. We have derived an expression for phi 1 and theta 1 in order to have the portfolio pi 1 to be replicative strategy, right? So when you substitute phi 1 and theta 1 into this expression, we have shown that it can be written like this, which is nothing but, which we have shown to be equal to HTU divided by 1 plus R into P star plus HTD by 1 plus R into 1 minus P star, where P star is the risk neutral probability. Now we will prove that we can in fact take the option price to be equal to the initial investment into the replicative strategy. How will we prove this? First, assume that H naught is greater than phi 1 into B naught plus theta naught S naught. Remember, this is equal to E star HT star. Therefore, just for the notational convenience and for a clear argument, we are taking the basic definition of V naught. Otherwise, you keep in mind that H naught is equal to V naught, which is equal to phi 1 B naught plus theta naught S naught is what exactly we have to prove, but this we have rewritten like this. So you have to keep it in mind. So the idea is, as usual, we have to now construct a arbitrage portfolio. Construct a portfolio pi naught by making the following. Please note that the portfolio that we are constructing here is not the one which we are considering as a part of our trading strategy. See, this is different, and this portfolio is our usual portfolio, which we consider as phi naught is equal to B, S, and D. Okay. So just for the sake of trading strategies, we have decoupled this and we have taken only this much. But for usual discussions, we will always go back to our usual notation and consider this. Okay, so how are we going to construct this portfolio? First, write one option with premium H naught. Therefore, you will get rupees H naught by writing this option. Then go long in this portfolio. Remember, you are not going long in one particular asset. When you say that you are going long in the portfolio, it means you are buying phi 1 times B naught plus theta naught 1 times S naught. Sorry, this is theta 1 times S naught. So here also it is theta 1. Okay, so you are buying this portfolio means you are exactly doing what is suggested in that portfolio. If you are shorting, it means -1 of that portfolio you will take. If you are going long, it means +1 of that portfolio. Okay, phi 1 and theta 1 are some numbers. They can be positive or negative depending on whether you take a long or short position in that. Overall, if you say I'm going long in this portfolio pi 1, it means 1 into that portfolio. So you then invest the remaining money in a risk-free asset. So initial investment is given by initial investment into pi naught, okay, is given by V of pi naught of 0. So you are writing one option, right? Therefore, it is -1 into H naught plus 1 into phi 1 B naught plus theta 1 S naught. And the remaining money is you got H naught. In that you spent phi naught B naught, phi 1 B naught plus theta 1 S naught. Right? So this is what precisely the value of your portfolio pi naught. Remember, it has option component. This is your bond component and your stock component. So everything is mixed together here. You can see that this is equal to 0. Therefore, your initial investment is nothing in the portfolio pi naught. Now at t equal to capital T, what happens? Let us see. We can close the risk-free investment to get this money. You can see that we have invested H naught minus the initial investment of the portfolio pi 1, and that is amplified as per the interest rate, and then we can close the long position in pi 1 and receive this amount. You can see that the first component is phi 1 into B naught, and that is interest component is there, amplified 1 plus R. R is the per period interest rate, plus theta 1 into ST, because at the time capital T, the stock price is ST. So you will receive or spend the money as per whether this quantity is positive or negative, right? And then you will come to settle the short position in the option. Remember, we have written the option, therefore we have to settle it, in the sense that if the holder wants to exercise the option, then we will have to supply one stock to the holder, or maybe you can settle with the cash also, and thereby we will be spending the pay of HT, right? So this is what happens at t equal to capital T. Therefore, what is the value of the portfolio pi naught at the time t is equal to capital T? We have V of pi naught of capital T is equal to H naught minus phi 1 B naught plus theta naught S naught 1 plus R, right? This entire thing plus phi 1 B naught into 1 plus R, that is the risk-free part of your portfolio pi 1, plus theta 1 ST, that is the risky assets value, and then you have spent on the option by settling it. Now we have to show that the right hand side quantity is greater than 0, right? This is strictly greater than 0 is what we have to show. In that, you can see that this term is strictly greater than 0. Why? Because we have assumed that H naught is strictly greater than phi 1 B naught plus theta 1 S naught. So I'm always making this mistake of writing theta naught. Please keep it in mind. It is theta 1 always. So we have assumed H naught is greater than this quantity. Therefore, this entire thing is greater than 0. That is already given as per our assumption. And now we will show that this part is greater than 0. This is what we have to show. Note that pi 1 is a replicative portfolio. Here, since we are working only with the one-step method, we have only one portfolio pi 1 in our strategy. Therefore, I am calling it as replicative portfolio. If you have a process of such portfolios, then we will call it as a replicative strategy. But here it's just one member in that process. Therefore, I'm just saying replicative portfolio. Therefore, this phi 1 and theta 1 satisfies the linear system. Recall, what is that linear system? The linear system is given like this. And remember, if you take this is nothing but phi 1 b naught into 1 plus r plus theta 1 into this is S1, right? S1, or in this case, since we are in one step method, so T1 will be simply ST1, right? If the stock goes down, then ST takes this value, and correspondingly your payoff is given by simply HT. And similarly, if the stock goes up, then S0U is your ST and your payoff is HTU. Therefore, this also gives rise to this. Therefore, this is the equation which is written in two different cases. Okay. So therefore, whether the stock goes up or down, this equation is satisfied. Okay. Now look at this. This is exactly the same. Your left hand side is this and the right hand side is this. Therefore, they get cancelled with each other because your phi 1 theta 1 is a replicative portfolio. Okay, so this becomes 0 therefore, and you already have one term which is assumed to be positive. Therefore, your value of pi naught at T1 is strictly greater than 0. And that proves that you have got a arbitrage portfolio when H naught is strictly greater than this quantity. Therefore, H naught cannot be strictly greater than this quantity is proved. Now, as you know, we have to assume that H naught is less than this quantity and again construct a arbitrage portfolio. Let us now assume that H naught is less than phi 1 b naught plus theta 1 s naught. In this case, we will construct the portfolio pi naught as follows. You short the portfolio pi 1. This means do the opposite trade that are suggested in the portfolio. More precisely, you will be just multiplying -1 with your portfolio, right? And then take a long position in the option. Therefore, you will be paying H naught here. So you got phi 1 b naught plus theta 1 s naught by shorting the portfolio, and you spent H naught by going long in the option. Therefore, you are left out with this much money that you put in a risk-free instrument. That will give us the value of the portfolio pi naught at the time t equal to 0 as -1 into phi 1 b naught plus theta 1 s naught. That is because you have gone short in the portfolio pi 1, plus you are in a long position with the option. Therefore, it is 1 into H naught plus this money, right? So phi 1 b naught plus theta 1 s naught minus H naught. So you can see that they all get cancelled and you have 0. Now at t equal to capital T, again you carefully see what are all the situations of the portfolio pi naught and show that the value of pi naught at the time t equal to capital T is strictly greater than 0, where we have to use our assumption H naught is less than the initial investment of pi 1, as well as we have to make use of the replicative strategy. Okay, just like what we did in the last case, the same idea will go through here also, and you will get this, and therefore this is also not possible. This both cases implies that you are only left out with the case when H naught is equal to phi 1 B naught plus theta 1 S naught, and therefore that is nothing but your V naught, and V naught we have rewritten as E star into H star T. So you take this value as your option price. Let's take an example. On 1st of March, the stock is trading at rupees 1267 per share, say. Let us take R is equal to 0.0039, U is equal to 1.0576, and D is equal to 0.9155. Now for these parameters, let us try to see what will be the price of the option with K strike, where K is equal to 1260. Let's take the option to be a call option. By one-step binomial model, the price of the option is given by E star of H star T, right? What is H star? H star T is nothing but the discounted payoff. Now, what is the payoff? Let us see first. Payoff HT is given by HUT if you get a upward movement in the stock, and HDT if a downward movement comes, right? So that is nothing but, since it is a call option, we have maximum of 0, S naught U minus K if upward movement is there, and maximum of 0, S naught D minus K if the downward movement is observed in the stock. We are given S naught, which is 1267, U and D are given to us, and K is also given. Therefore, we can explicitly find what are these values. This is 80 if the upward movement is there, and 0 if downward movement is there, right? Now let us see how this formula explicitly looks like. It is H naught is equal to HUT. Since it is a call option, you can put a C here, by 1 plus R into P star plus HDT by 1 plus R into 1 minus P star. What is P star? P star is equal to 1 plus R minus D divided by U minus D, right? In our case, this is equal to 0.6222, like that it goes on. So therefore, it's approximately equal to this. 1 minus P star, therefore, is going to be 0. Again, approximately equal to 3778. Okay. So when you substitute all these values in the expression, you have 80 divided by 1.0039 into 0.6222 plus 0. So this is anyway 0, and that comes to be approximately equal to 49.58. So this is the price of the option suggested by the one-step binomial model. Next, let us extend our option price model to a multi-step model. The idea is to divide the entire binomial tree into single subtrees. Recall that in a binomial lattice model or tree model, you have S0, then you have two possibilities. One is up, that gives you S0 U as the price at t equal to t1, and S0 D at t equal to t1. If the expiration capital T is equal to t1, we know how to devise a model to obtain the price of the option. That is one step model. And if you are having, say, multiple steps, then the idea is to split them into one steps. For instance, let us take one more time level and consider t equal to t2 as your t and not this one. Then what happens? You have further four possibilities. That is, if your first step goes upward and then the second step also goes upward, then you have S0 U, and if these in the second level, if the stock price goes down, then it is S0 UD, right? Similarly, if the first level goes down and the second level goes up, that is the stock price goes up in the second level, then you have S0 DU and S0 DD if it goes down, right? Now you can see that this is one single step subtree, and similarly this is another single step subtree, and you have this as one more single step subtree. Therefore, in a two-step method, you have subtree 1, subtree 2, and this is your subtree. There are three subtrees, and so this together is actually a two-step method. Now, if you have one more time level, that is t equal to t3, and your expiration is at t3, then you have 8 chances from level 2 to level 3, and you have 4 sub-tree cases in that level, 4 plus 3. So you have totally 7 sub-tree cases in the three-step method, and so on. So it goes on like that. Let us first try to understand how to get the option price in a two-step model, and then we will generalize it to multi-step models. In a two-step model, the time partition T2 is given by T0, which is 0, T1, and T2 is taken as the expiration time. And what is your sample space in this case? It is U, then U, that is this case U, then UD, which is this case DU, and DD, which are this and this respectively. So this is the sample space given to us, and at each time level we have the partitions of S, which are denoted by P1 and P2. What are they? They are the following. At time level t equal to t1, the partition of S, now this is the partition of S, is BU, BD, right? What is BU? BU is the set of all outcomes when the first one was an up, right? That is, first one is up, then the second one is up, first one is up, and second one is D, right? That is your BU, and VD is the set of all outcomes for which the first movement is a downward movement. That is D and then up, D and D. So you can see that P1 is a partition of S, and at time level T equal to T2, the partition is given by BU, U, BU, D, BDU, and BDD. Each one is a singleton set, right? BUU is nothing but UU, and so on. So this is how the partitions are given to us. And let us see what is the payoff at time t equal to capital T. We will denote it by H2. We generally denote it by HT. So we just have the notation H2, and that is given by H2 or HT, whatever you like, you can put. That is HUU. That is when the stock went up in the first level and up in the second level also, then your payoff is nothing but maximum of 0 comma S naught UU minus K, right? That I am denoting by this on BUU. That is this case. Remember, HUUT is, if it is a call option, it is 0 comma S naught UU minus K for call, and if it is put, how it will look like, it is 0 comma K minus S naught UU, right, for put options. And similarly, all the other cases can be written. I will not repeat it. Coming back to the expression of H2, you have HT, you can also put as H2 here, UD on BUD. Similarly, you have HDU T on BDU, and finally you have HDDT on BDD. So this is how your payoff is given. Generally, we use the notation HT, but here just to go backwards, then the next previous level payoff we will take as H1, and then the 0th level, which is also the price, we will take as H0. Therefore, to have that clear notation, I am just calling it as H2. Now comes the important step. We have to now write H1. What is H1? H1 is interpreted as the payoff at this time level. Okay, you can think of as the value of the option at time t equal to t1. That is the intrinsic value of the option at time t equal to t1. So how are we going to get this? Is you just imagine that you have only one tree and you start with this price and you build the one step model with these two as the possibilities. Then what is the price of that option as per the one step method? If you recall, we have shown it in the last lecture that it is E star of this part. See, we have HT star we put, right? Now, it's not the HT star. HT star is the discounted payoff, the entire payoff. But here we have only this sub part alone we have to take. Therefore, we will make one new notation and write U star, HTU star or H2U star you can put. This happens when you have the first one was U. That is, the first level was up. How we notationally represent it? We represent it as BU, right? In the first level, if the stock went up, then all possible outcomes are denoted by this symbol. Okay, you define your H1, which is one step behind. Okay, if you would have started at H1, you would have reached H0. Okay, that is what in the last theorem we have given H0 equal to this. Okay, now we started with T equal to T2. Therefore, one step if you come behind, you reach H1, and you are applying the one step pricing model to this subtree case, and you are getting this. If you want, we can put it as H2U star to have a clear understanding on the notation of at what level we are writing this. Similarly, if you have taken a downtrend in the first level, then it is E star of H D star 2. Now, how will you define H2U star and H2D star? See, H2U star is given by this. These two are together equal to H2U, and you have a star there. Therefore, you have to discount this. So, H2U star is given by 1 plus R. If you recall, in the last class, we have seen that this is a discounted payoff, right? Into HUUT, if you have BUU, that is this both up direction, and H first is up and then the second is down, that is this one. You have UD, right? And then this comes like this, where this is HUUT is given by this. And similarly, HUD will be given exactly like this, but instead of you have UD there. That's the only difference. So you are given like this. Similarly, you can write what is H2 D star. Okay, so that also you can write. And as usual, E star is the expectation of this random variable with respect to the risk neutral probability. That also we know. So your payoff at the level 1 is obtained. There you have used the one step binomial model like this, and you obtained it. From here, we have to go one step further backward to achieve H0. How will the H0 be given? H0 is given by, again, your one step binomial model you take. It is E star of the discounted pay of H1, right? Discounted pay of H1 is H1 star. I would have ideally used a tilde there, but since I have used a star here by mistake, I'm just continuing that notation. Otherwise, in the last class, we have used a tilde for discounted random variable, where H1 star is nothing but H1 divided by 1 plus, and this is what we finally take as the price of the option, okay, as per the two-step model. And you can see that H0, I will give you the explicit expression for this. You can easily derive it. It is 1 by 1 plus R square. How it is coming? Is the one discount 1 plus R is coming from here, and another discount 1 plus R is coming from here. This is of course quite natural because you are having two steps. So the first step discount is coming from here, and the second discount is coming from this level. And then you have HT UU, right? That happens with probability P star square, two levels. One P star comes with one U, another P star comes with another U, plus HT DU plus HT UD. U brings a P star and D brings a 1 minus P star. right? I'm just writing the expression for this term E star H1 star. Okay, you can just substitute all these expressions into this and get this expression. I just give you the final expression, you can check that, plus HT dd, right? Each d is happening with probability 1 minus p star, therefore there are two d's, so you have square here. So this is the explicit expression for the price of the option in the case of two-step model.